All right, the next thing I want to do is just show you this table that I've created that has all the Laplace transforms that we've talked about so far listed, hopefully in a nice order. And this is a handout that I've put on our Canvas site. So if we just hop over to our Canvas site for differential equations, it's in the modules link. Ignore some of the stuff. In fact, let me make this so it's like you can see it. So this is basically the version that you have with without the annoying pink bar at the bottom. But you'll have this Laplace transforms handout. Okay, so it's this handout right here. Okay, so this handout. And that's our Laplace transforms handout. So what I want to do is I want to show you how, I basically just want to show you this table. So this is a table that we have of all the Laplace transforms that we've talked about so far. I will still talk about these items down here. So items 28 and so on. In fact, 37 we've already talked about, it's just the gamma function. But I owe you just a little bit more, just a few more videos on those there, and then I owe you a few more videos on actually implementing all these ideas to solve differential equations, because we've spent a lot of time going over the theory about how all these work. But I just want to kind of hit the highlights here. So I have the definition of the Laplace transform. The fact that the Laplace transform is linear can be written in one succinct step. And then I have basically all the Laplace transforms that we went over in order. So the Laplace transform of any constant function, or really just the Laplace transform of one. We have the Laplace transform of cosine and sine, exponentials, which leads us to cosh and sinh. If I have t to any power, notice that I changed this from t to the a from the video to t to the p, where p is any just real number that's bigger than -1. So that has a nice formula for it that we talked about in the video. The Laplace transform of t to the n. So this just really is just using number 9, together with the fact that we know that the gamma function evaluated at n+1 is just n factorial, right? So that's why this works out the way it does. So the Laplace transform of t to the n is n factorial over s to the n+1. That's only valid when n is greater than or equal to 0. And then the Laplace transform of f prime, and then the nth derivative of f. Okay, so we talked about those. And then we also further talked about these transformations. So if you multiply f by an exponential, you get a certain pattern. Okay, and we talked about all these consequences. We just recently talked about if you take the Laplace transform of f over t, okay, you end up with this integral. And then the final one is if you were to multiply by t, rather than, so before we had multiplying by e to the at, but if instead of multiplying by e to the at, if you multiply by t, you end up with a different transformation. So again, we talked about that. This is all the steps written out. All the videos that we went over cover items 1 through 27. Okay, so what we're going to do, and I actually want to stop talking about theory for a while and just kind of solve some differential equations. So one of the things that we'll do next is let's solve a differential equation that we couldn't before. Okay, so that's our next step. But anyways, this table of Laplace transforms is up on Canvas. Feel free to print it, use it for exam 3 and for the final. It's totally fair game. If you want to just print this, use it, and there we are. Okay, so that's this Laplace transform handout.